Meet Pierre. Pierre has a problem. By day, he is a 17th-century French lawyer. He wears a wig, he listens to boring lawsuits about unpayable taxes, and he signs paperwork. He is the ultimate bureaucrat. But by night, Pierre leads a double life. When the candles are lit and the rest of France is asleep, Pierre de Fermat transforms. He isn't just doing math, he is rewriting the laws of reality. History calls him the Prince of Amateurs. I call him the Clark Kent of calculus. Because without ever quitting his day job, this quiet lawyer managed to outsmart the greatest geniuses of his generation. Here is the crazy part. Fermat never published. His contemporaries, Descartes, Pascal, Newton, were obsessed with fame. They wrote books, they gave lectures, they argued in public squares. Fermat just didn't care. He did math for the sheer joy of it. He would solve an impossible problem, scribble the answer on a scrap of paper, and then send a letter to the experts saying, "I figured it out. Good luck." He wasn't trying to be mean. He just didn't have time to write textbooks. He had court in the morning. But look at what he accomplished in his spare time. Exhibit A, Analytic Geometry. You know the x and y axis? We credit René Descartes for that. But Fermat invented it first. He was sketching 3D graphs while Descartes was still figuring out the basics. Fermat just didn't think it was a big deal. Exhibit B, Calculus. We are usually taught that Newton and Leibniz invented calculus. But 13 years before Newton was born, Fermat was already calculating slopes and tangents. Newton even admitted it. He explicitly stated that he got the hint from Fermat's method. So really, Newton and Leibniz built their empires on Fermat's unfinished homework. Exhibit C, The Nature of Light. Fermat had a radical idea about physics. He argued that nature is fundamentally lazy. He claimed that light always takes the path that requires the least amount of time. It takes the shortcut. At the time, people thought he was crazy. How does the light know which path is fastest? They asked. But he was right. This principle of least action is now the backbone of modern physics, from quantum mechanics all the way to the GPS in your phone. And finally, Exhibit D, Gambling. One day, Blaise Pascal writes to Fermat with a question about a dice game. If we stop the game early, he asks, who gets the money? To answer this, they didn't just do math, they invented probability theory. They took the chaotic, random mess of the real world and tamed it with logic. So, if you have ever bought car insurance or checked a weather forecast, you can thank the French lawyer. But Fermat's true passion was numbers. Pure, simple numbers. He loved to look for patterns that no one else could see. And this brings us to the moment that made him a legend. He is sitting in his study, reading an old Greek textbook. He is looking at the formula for a triangle, a squared plus b squared equals c squared. He starts wondering, what if we change the exponent? What about a cubed plus b cubed equals c cubed? What about the power of 4? Or 5? He tests it. And he realizes something terrifying. It never works. The equation breaks for any number higher than 2. So, he dips his pen in ink, and he writes a note in the margin of the book. I have discovered a truly marvelous proof of this, which this margin is too narrow to contain. And that was it. He never wrote it down. He never told anyone. And then, he died. That little note became the biggest cliffhanger in the history of science. For 358 years, the smartest people on Earth tried to find the proof that Fermat claimed he had. It became the Holy Grail of mathematics. It drove people obsessed. It ruined careers. It wasn't until 1994, literally the year the PlayStation came out, that a mathematician named Andrew Wiles finally cracked it. But he had to use modern, 20th century math that Fermat couldn't possibly have known. So, did the lawyer actually have a proof? Probably not. He likely tricked himself. But does it matter? In his search for a solution, he forced the rest of us to invent entirely new branches of mathematics. Pierre de Fermat showed us that you don't need a research grant or a university title to change the world. You just need curiosity, a quiet room, and apparently, a book with really, really small margins.